Hello everyone, back tuning into Solar Sunday. So very exciting day at Gazovids today because it's only our second Solar Sunday of the year. Probably won't be another Solar Sunday this year. We like to do 3 if we can, but I'm not sure we'll be able to fit another one in before we start the winter update. So this is possibly going to be only the second and final Solar Sunday of the year. So it's always a very special day at Gazovids when we do Solar Sunday. I'm going to bring you up to date first of all with this, with all of the trackers, all of the charts that we always show you in our Solar Sunday update. So you'll see how things are progressing for Solar Cycle number 24, and we'll bring you up to date with where we are in the Solar Cycle for the first part of the video. Then the second part of the video is going to be very complicated, very complex, and a little bit of science will be in there as well, because we're going to look at the relationship between solar activity and volcanic activity, volcanoes. Now, I got to 30 minutes with the first version of Solar Sunday, and I was messing it up. So it'll be very interesting to see whether this records successfully or not. But do please bear with me, because it's going to be very complicated discussion that we're going to have in the second part of the video about volcanic activity and solar activity via cosmic rays. So more about that in a few minutes, but we're going to begin by having a look at your updated trackers. Big thank you to James Acrill for supplying all of the information, or nearly all of the information in this video. Also, my good friend Richard Draught has provided some input into this video as well. So big thank you to James and to Richard. If I make any mistakes, it's entirely my fault. It's not their fault at all. So I'm sure you'll let me know through the description box at YouTube, through the comment box I should say. I'm sure you'll let me know if I've made any mistakes, and let's just see how we go. I'm going to try and take it slowly and just sort of unveil the information as best I can. Just say it's going to be quite a long video, so you can't watch it all and go. We place on the Solar Cycle 24-25 updates page later on today with a written summary as well, just going over everything that we discussed in the video. Right at the very end of this video, we will actually go back to the first Solar Sunday that we did back in February. Got a little bit more information about that in terms of Maunder Minimum and that kind of thing. So a little bit more information right at the very end of the video in relation to the first Solar Sunday that we did this year. But starting it all off is going to be a look at the solar disk on our side of this today from solarham.net. So let's begin there, shall we? And this is the solar disk on our side of this today from Solarham, and you see that we have got pretty much an entirely spotless solar disk. We have no sunspots to be seen. We are moving inexorably now into solar minimum. So this, updated by our good friend James Acrill, is the Gazovids Solar Sunday Solar Activity Tracker, updated as of the 9th of June. And you can see what's happening with the Solar Activity Tracker is that we are just here. So those, that's depicting the spotless condition that we have on the solar disk on our side of the disk at the moment. Now, we haven't looked at this for 2 or 3 weeks in the Sunday roundups. By the way, there will be a Sunday roundup coming up later on today, but we haven't looked at this in the Sunday roundups over the past couple of weeks. So I can tell you that actually through the middle part of May and the second half of May, we did have a little bit of a spike up in solar activity again, and it wasn't enough to lift our trend lines, which are the thick green and the thick red lines. It wasn't enough to lift those trend lines upwards. But now we have these spotless conditions occurring on the solar disk at the moment, and that is enough to begin to lower the trend lines once again. Now, back earlier in the spring, back around March and start of April, we went into a very, very minimal level of solar activity indeed. And at that point, there was quite a bit of speculation about whether we might be going into the true solar minimum of this solar cycle. But I think we can see with the lift up in solar activity that we've been in over the past few weeks since the latter part of April and then through May, that we aren't yet quite at true solar minimum. But we will be very, very shortly at true solar minimum. This is showing solar cycle 24 from its start to where we are right now. So each orange spot here is depicting each individual month's sunspot numbers. So that's where we are right now, obviously at a very, very low level of sunspots indeed. This is the beginning of solar cycle 24 just here, back in 2008 and the start of 2009. We see that we had that very slow, gradual lift up in solar activity, which took a long time to really take off through the early part of this solar cycle. But eventually we did arrive in our first peak of solar cycle 24, which occurred in the latter part of 2011. Then through 2012, we went for a really weak phase of solar activity. Considering we was around a solar maximum, we went for a very, very weak phase of solar activity indeed, before we arrived at our second peak of solar cycle 24 that occurred at the beginning of 2014. And that second peak was actually the solar maximum of this solar cycle, which is quite unusual. Normally the first peak will be the solar maximum and the second peak will be a little bit weaker, but this solar cycle did things a bit differently. Then after that, we get this drop down into, quite a slow drop down to begin with, but certainly accelerated over the past year to 18 months, a drop down in towards solar minimum. So as I say, that's where we are right now with our sunspot number for May coming out just there. At a higher level though, compared to sort of the end of 2017 and the first months of 2018. So this tells us we're probably not yet quite at true solar minimum. This is what a true solar minimum period looks like just here at the beginning of this solar cycle, where these orange spots are virtually on the bottom of the chart over those monthly periods. So over monthly periods, there's barely any sunspots taking place at all. So almost at true solar minimum, but not quite. Compared to where we was at the beginning of this solar cycle, so we're probably where we was back in the middle of 2009 in terms of monthly sunspot numbers now. So not the solar minimum year of 2008, but certainly very, very close now to being at solar minimum. This is solar cycle number 24 compared to solar cycle number 23, the last solar cycle. And again, just depicts how much weaker this solar cycle has been. So this is the double solar maximum of solar cycle number 23 just here. The solar cycle itself, solar cycle 23, begins in 1996. We see a much more rapid increase into the solar maximum, just a quick ramp up, a much quicker ramp up in monthly sunspot numbers there for solar cycle number 23, reaching the peak in 2000. Do get the double peak in solar cycle 23, get the first peak in 2000 and the second peak occurring at the beginning of 2002. But this one much more typical because the second peak is actually weaker compared to the first peak. So the first peak of solar cycle 23 in the year 2000 is the solar maximum of that solar cycle. And then this long drop down into solar minimum, and then the very, very long solar minimum indeed through 2008, through 2007 really, into 2008, and then on into 2009 as well. And only really started to see the solar cycle number 24 lifting up, and then only very gradually and slowly through 2010 into 2011. But just compare how flat this solar cycle is, number 24, current solar cycle, how flat it is, how slow it is to lift off compared to the very rapid ascent that we see there as we lift off into solar cycle number 23. Quite remarkable differences between the two solar cycles. Where we are right now, solar cycle 24 is just there, roughly at this point in solar cycle number 23, we would be around there. So kind of like where we was in the middle of 2007. So solar minimum of solar cycle 23 occurred in 2008. So just around 6 months, 12 months or so away from solar minimum, if we use the comparison of the last solar cycle, number 23. This chart's depicting all solar cycles going back to solar cycle number 1. So that's number 1 up there. This is the current solar cycle, number 24, down here. You can see that, again, we are at a very low level of solar activity with this solar cycle. So most of the maximums, most of the solar maximums of all of these solar cycles are around here, that part of the graph. Solar cycle number 24 is depicted by the red line, and that is down there. So you see that we are amongst the very weakest of the solar cycles all the way back to number 1. And we still are, interestingly, as we go into solar minimum, that's where we are right now, at just about the lowest level of all of the solar cycles going into a solar minimum. They all will eventually, or they all do eventually converge around there at solar minimum. But you can see, compared to most of the solar cycles, we are, as we have been throughout the whole of solar cycle number 24, at a really very low level, and certainly well below the same point within the solar cycles, certainly below most of the solar cycles going all the way back to number 1. So these are the weakest solar cycles compared to number 24. So we've got solar cycle number 5, solar cycle number 6. Those are the two Dalton minimum solar cycles, of course. And then we've got solar cycle number 12, solar cycle number 14, solar cycle number 16, and then finally the red line is solar cycle number 24. So what's interesting is that out of these solar cycles, the two that have the weakest solar maximums are the two Dalton minimum solar cycles, number 5 and number 6. So not really on a par with those. We're up here with numbers 12, 14 and 16. But interesting, as we go down to solar minimum, and that's where we are right now, heading into solar minimum, you'll notice that solar cycle number 6, that had that weak solar maximum, very weak solar maximum, actually at this point, going into the solar minimum of solar cycle number 6, it was one of the stronger of the solar cycles compared to these other very weak solar cycles. Eventually, of course, they do all converge around there, and they go into the true solar minimum of these solar cycles. Now, throughout this solar cycle, number 24, there has been a connection, there has been a comparison to solar cycle number 12. That's depicted in this chart of the weakest solar cycles, of course, back to number 1. So we've been tracking solar cycle number 24 in comparison to solar cycle number 12 for quite some time now. Solar cycle 12 occurred from 1877 to 1890. Might be a little bit out with the years there, but you can see the way the trends have gone, very similar. So they both had, and by the way, the green line here is solar cycle 12, the orange line, or the brown line, is solar cycle 24. So you see they both have that very, very weak, protracted solar minimum. Both very, very slow to lift out of solar minimum into the solar maximums. Both very weak with the solar maximums, and both, interestingly, having a double peak maximum. That's not particularly interesting. Most solar cycles do that. But both of them, or with both of them, the first peak, which occurs there, let's get rid of that. The first peaks which occur just there, for solar cycle 12 and 24, is actually weaker than the second peak, which occurs just there. So again, that's quite unusual for that to happen, and both of these solar cycles did that. And then the rather rapid descent down into towards the solar minimums, and so that's where we are right now for solar cycle number 24, the current solar cycle. We're at this very low level of solar activity, but we are on a par with solar cycle number 12 as well. And so you assume we're probably going to finish this solar cycle in a very similar way to solar cycle number 12, as we've been tracking it, tracking very similar, very much along the same lines with these two solar cycles. And solar cycle 12 is interesting with its minimum because it is a little bit up and down, so we don't get a prolonged sort of run of months that don't have any sunspots with solar cycle number 12. So it may be, if we continue to track along the same lines, it may be that we won't get a prolonged run of no sunspots as we end solar cycle number 24, and that make it quite difficult to determine when we've actually left solar cycle. Actually make quite difficult to tell me when we've left solar cycle number 24, the current solar cycle, if we do that, because that's speculative. It may be that this solar cycle will finish up doing something different compared to solar cycle number 12. So that's pretty much brought you up to date with all of the solar information in terms of the trackers and the charts. The next part of the video is going to explore the relationship between volcanic activity and solar activity as well via cosmic rays. I'm just going to pause the video there, get a little drink of water. We'll meet back in around 2 minutes. I'm going to go over my notes and see if I can make myself more certain about this part of the video. So I'm going to go over my notes, get myself a drink of water. You're going to get yourself a cup of tea, a couple of biscuits. We'll meet back in around 2 minutes, and we'll explore the relationship between volcanic activity and also solar activity. And then at the end of the video, we'll have a little bit on what we talked about in February's solar Sunday, and the Maunder Minimum. So come back in around 2 minutes time. Okay, and we're back. I'm just going to check to make sure that we're recording. Yes, we are. Okay, so we're going to talk now a little bit about solar activity and volcanic activity via cosmic rays. So a little bit of science coming into the video now. We'll see how I get on with this part of the video. As I said, I actually did a recording for this Solar Sunday a little while ago. I had to stop it because I got a bit mixed up with all of the information, so I'll see how I get through it now. I'm going to try to rattle through, and I hope you'll be able to follow it. And then at the end of the video, we're going to have a little bit about what we talked about in February's Solar Sunday in terms of the Maunder Minimum and potentially current weather conditions, but that'll be coming up in the final minutes of the video. Let's deal with volcanic activity. We've got to look at cosmic rays really for this. So I'm on the Wikipedia page for cosmic rays. I'll just read you the first sort of paragraph summing up what cosmic rays are. So cosmic rays are high-energy radiation, mainly originating outside the solar system and even from distant galaxies. Upon impact with the Earth's atmosphere, the cosmic rays can produce showers of secondary particles that sometimes reach the surface, composed primarily of high-energy protons and atomic nuclei. They are of uncertain origin. Data from the Fermi Space Telescope have been interpreted as evidence that a significant fraction of primary rays originate from the supernova explosions of stars. Active galactic nuclei are also theorized to produce cosmic rays. Now, there's an inverse relationship between cosmic ray intensity and sunspot numbers. So cosmic rays become more intense when you go into solar minimum. So cosmic rays increase around solar minimum due to the sun's energetic activity and magnetic field becoming weaker, allowing more cosmic rays into the inner solar system. This would usually be deflected around solar maximum when activity and fields around the sun are at their strongest. So that's the reason we see this inverse relationship between cosmic ray intensity and solar activity, solar minimum. So you can see that the solar minimum just here, occurring around 1976, has a very strong period of cosmic ray intensity. And then again, the solar minimum around then, the mid-1980s, 1985, 1986, occurs around another period of intense cosmic rays. Again, we see it in the middle of the 1990s as solar cycle number 22 draws to a close. We get that solar minimum occurring around 1995, 1996. At the same time, we're going into a strong period of cosmic ray intensity. And then we see it again with the last solar minimum of solar cycle number 23 in the mid to late 2000s. And look how strong the cosmic ray intensity was then. Of course, we know this was a much weaker solar minimum that occurs there in the mid and late 2000s compared to these other solar minimums, which are rather weaker but are occurring just here. Those three, they aren't particularly weak solar minimums at all, and they soon lift off into their next solar cycle. But this last one does things differently. It's a very very long solar minimum and only a very gradual lift up into the solar maximum of the solar cycle. And so we have a stronger period of cosmic ray intensity. In fact, it's a more intense period occurring over a longer period of time. So when we're in these weak periods of solar activity, so cosmic ray intensity tends to increase. Now, the way this works is that cosmic rays hit the upper atmosphere at near light speed. A shower of various particles, some subatomic, are then produced, and some of these particles will penetrate right way down into the Earth's surface, and that's particularly the muon particle that will penetrate right away through towards the Earth's surface. And so this chart is depicting how this works. So we've got the primary cosmic rays up here coming in from space, and they're going into the atmosphere, and you see they're splintering off into different directions. But some of them, not all of them, get down to the Earth's surface. Some of them are finishing around here in the atmosphere. But some of these cosmic rays are in fact, or some of these particles are in fact hitting the Earth's surface and actually penetrating through the Earth's surface. And so this is a very interesting paper. This is the explosive paper looking at explosive volcanic eruptions triggered by cosmic rays, volcano as a bubble chamber. I'm going to leave a link to this paper within the description box at YouTube, and this sort of explains how it all works. So explosive volcanic eruptions triggered by cosmic rays, volcano as a bubble chamber is the title of the paper. And it sort of explains that it's been found that muon particles produced from cosmic rays penetrating into the subsurface of the Earth heat up and excite silica-rich magma and magma chambers within the particularly stratospheric volcanoes, leading to an increased threat of explosive volcanic eruptions. And so that's the mechanism by which this works, and we have in fact seen an increase of volcanic eruptions through the course of this solar cycle. So this chart is from I think it's Met Bunk, and this has been supplied by a good friend, Richard Trott. And again, we go back to 1945 with this, so we can see the volcanic eruptions that have been taking place going back to 1945 just there. That's 1955, that's 1965, that's 1975, that's 1985, that's 1995, that's 2005, and we aimed at 2015, so unfortunately we aren't up to date, but it does depict the increase in volcanic activity that has occurred around this period of weak solar activity. So if you think that this period just here, where we've got these volcanoes sparking off through these years, which is kind of like mid to end of 2000, so that's 2005 just there. So we've got sort of 2006, 2007, 2008 within this period, and of course, that's the prolonged and protracted solar minimum of solar cycle 23 and the start of solar cycle number 24. And we see a lot of volcanoes going off around that point. And then this period just here would be kind of like the solar maximum of solar cycle number 24. But bear in mind, it's a very weak solar maximum. So whilst we see all these years down here, which are kind of like very low-level volcanic years, and they would primarily be occurring very close to the solar maximums of their various solar cycles. With this solar maximum, because it was such a weak solar maximum overall, we keep relatively high levels of volcanic activity going even into kind of like the solar maximum years, which is really quite interesting, I think. And it does tell us that even through the solar maximum, we're probably keeping a lot of cosmic rays coming into the Earth's atmosphere, and so we was probably getting quite a lot of those muon particles down onto the surface and into the magma chambers of these volcanoes, even through the maximum period of this solar cycle. And it's just unfortunate we can't see now how things are looking in terms of the last year or so, as we've decided to move back into solar minimum again. I assume that this brown line, which is kind of like the 10-year trend, I assume that would be moving upwards again, because we have seen a lot of volcanoes just over the past month. This is the full list of volcanoes that have been sparking off. Now, I'm not going to try to attempt to pronounce all of these, but James has compiled these, and a huge number of volcanoes have been sparking off over the past 8 months. So in Mexico, in Peru, in Costa Rica, in Guatemala, in Ecuador, Italy, the Aleutians, Hawaii, Vanuatu, not sure where that is. Russia, of course, we've got volcanoes sparking off there. Solomon Islands, Japan, Indonesia, Philippines, and Papua New Guinea. All of those areas have seen large volcanic eruptions over the past 8 months alone. And so there does very much seem to be this relationship, this connection between volcanic activity and particularly around weak periods of solar activity. And of course, because it's been such a weak solar cycle overall, it explains why even through what you would think it's like the maximum, solar maximum period of this solar cycle, where you'd expect volcanic activity to be quite a low level through that period, because we're not getting the cosmic rays and thus the muon particles down to the surface of the planet. Because the solar maximum has been so weak, we have continued to see quite high levels of volcanic activity even through the solar maximum. But I would suspect, as we're going to go further into solar minimum, and we may well have quite a slow movement from solar cycle 24 to 25, I would suspect it's very likely, actually, that we will see a lot more volcanic activity occurring over the next year or two. So it's going to be very unfortunate for all those people that are caught up in this volcanic activity. But I would expect we will see a lot more volcanic activity coming up over the next few, won't say the next few years, but certainly the next year or two, I suspect we will see more volcanic activity. Finally, I just want to go back to February's Solar Sunday. Whew, I got that done and out of the way. Thank goodness for that. I've been worrying so much about that. Now we'll just go on and have a very quick look at the past solar cycles and the last Solar Sunday that we did in February. So this was up until this Solar Sunday. You have to let me know what you think about this Solar Sunday, but certainly up to this Solar Sunday, this was the most epic sort of not only Solar Sunday but most epic video that I've ever done, because it covers such a huge time frame. If you remember, we looked at solar cycles going right way back into kind of like the Dalton minimum, and we also went forwards into the potential solar cycles coming up in the rest of this century. So we went to 2100 and we sort of expanded out over around 500 years. So I showed you this chart, which is 400 years of sunspot data going beyond solar cycle number 1. That is solar cycle number 1 just there, but we went further back than that. We went right way back to like 1600. And then through to the year 2000, and then as I just showed you, we also went further than that, and we went to 2100. It's kind of like 500 years worth of data that we was talking about. But we did include in that period the Maunder Minimum that occurred between 1645 and 1715. This was a very, very low level of solar activity. Look how weak the solar activity was through the period of the Maunder Minimum. So even compared to like the Dalton minimum, those two solar cycles of 5 and 6 occurring just there. Let's get rid of all the lines. So that's the Dalton minimum period of 5 and 6, which is a very low level of solar activity, of course, but much, much weaker than that with the Maunder minimum. And we did show you this chart as well, which is kind of like a reconstruction of the Maunder Minimum from NASA, the temperature change that occurred through the Maunder Minimum. So I'll just deal with that first one, and then I'll talk you through the chart that is on the right of the screen as you're looking at it. So we'll just quickly go over this chart again. This is the temperature change reconstructed by NASA for the temperatures that occurred across particularly Northern Europe, but we also include North America as well during the Maunder Minimum. So the temperature change was something like 2 degrees down through the winter temperature change, something like 2 degrees down through the Maunder Minimum through most parts of northern Eurasia, and of course the British Isles was included in that. Not everywhere gets cold from this though. You'll notice in the middle of the Atlantic actually temperatures did increase during the Maunder minimum. We went to kind of like increased temperature by kind of like half degree or more through the middle part of the Atlantic. So not everywhere got colder during the Maunder Minimum, but the populated areas of kind of like Europe and Eurasia over here and North America over there, the populated areas, well, they weren't particularly populated back then, of course, but they will be populated now. Those areas did get substantially and significantly colder. Now, what you're looking at with the chart on the right is the temperature composite anomaly set against 81 to 2010 averages for this past winter, from January through to April, so kind of like the 3 months from 15th of January to 15th of April. And look at the profile that is happening there. So we see, again, most of Eurasia is going very cold. Little bit different compared to the Maunder Minimum period in the Atlantic, in that the Central Atlantic was actually quite cold as well, and the warm area is pushed back into the pole. That's where the blocking is, of course, through the pole. But we do see on this reconstruction from the Maunder Minimum temperature change chart that it did, over the very centre of the North Pole, it did actually warm ever so slightly. And then, of course, we got this cold area from Canada sinking down into North America, not anywhere near the same extent as we had during the Maunder Minimum period, but nevertheless, kind of similar. And then we have these warmer anomalies going on down here, kind of across North Africa and into the Middle East, and that's kind of similar to that as well. So what do we think? Do we think there's a similarity there? I think there's a similarity there between the temperature change that occurred during the Maunder Minimum and the temperature change or the temperature anomalies that we had during the winter of 2018. Now, that's just one winter. Of course, the temperature change that occurred during the Maunder Minimum is stretched out over many years. So we can't say that because we've had one winter that looks quite similar to the temperature change that occurred during the Maunder Minimum during 2017-18, that we are definitely off and running into a Maunder Minimum type period. You would need to see that extending out over many subsequent winters before you would be able to say that there is a true comparison. But it certainly is quite interesting. It's certainly something that we should probably, because we're at such a low level of solar activity overall, although not at Maunder Minimum levels, have to emphasise that, almost certainly not at Maunder Minimum levels of solar activity. Because there is a similarity, we probably have to keep an eye, similarity in terms of solar cycles, we probably have to keep an eye on these winter temperature anomalies over the next, particularly I would have thought the next 20 to 30 years. It'll be very interesting to see how that plays out. Finally, I just want to finish with the Patreon page. So if you found this video interesting and informative, and you would like to see more content like this, then we are primarily ads funded at Gav's Weathervids. But we have just in past weeks set up a Patreon page. So if you would like to see more content such as Solar Sunday, do please give us a donation to our Patreon page. I'm going to leave the link within the description box at YouTube. We're linking to it at Gav's Weathervids, the website as well. Give us a little bit of a donation, and you'll be able to see more content like Solar Sunday brought to you via Gav's Weathervids. Of course, particularly the website does cost money for us to have the website and to continue to upgrade the servers and all of that kind of thing. So if you could spare a little bit of money to give us a donation to become a patron for Gav's Weathervids, then that would be really great, and thank you everybody for doing that. So we have got 11 subscribers, so big thank you to those 11 patrons for Gav's Weathervids. And that's it. That is your Solar Sunday for June. Hope I did it okay. I think it went all right. As I said at the video, if there's any mistakes in there, it isn't down to James or to Richard. It's entirely down to me. So I can only apologise if I got anything wrong with the information that you heard. I think it went okay. I think you was able to follow it. I hope you was able to follow it and found it interesting and informative. As I said, this may be the last Solar Sunday that we do this year. We'd like to do 3. Normally we do it in February, May and August. But we've had to push this one back to June, of course, because of the summer updates. So we probably will try and fit one in August, but by August, of course, we're talking about the autumn updates a lot, so it just depends whether the slot opens up. And then after August, really time has run out, because then we're into the winter updates from September through to the end of the year, and we cover solar activity in depth in the winter updates anyway. So this may be the last Solar Sunday of 2018. We'll try and get one in if we can at some point through August, but if we can't, then I just hope you found this Solar Sunday and February's Solar Sunday interesting and informative. And at 38 minutes, a big thank you to James again and to Richard for giving me the information that you've heard in this video. And I'm going to stop it at 39 minutes, so all that remains is to say thanks for watching and come back very shortly for the Sunday Roundup. That's all for now. Thanks for watching.